Now, we're supposed to do animal research before we do people research. In humanized mice, so that was mice that we gave ACE2 receptors to so we could work with them on this. After 2 weeks, 95% of the animals were dead. When we looked at those animals, we saw this under the microscope. This kind of looks like a sponge, right? This is what it's supposed to look like, all this. But this is what happens, and this looks like a sponge, and it's in the brain. So in medicine and science, we call that spongiform encephalopathy. Okay? And the general public calls this mad cow disease. We also know in rhesus macaque monkeys, because those are the closest thing to us to use as a model to see what will happen to us, that in 5 to 6 weeks, when the animals were sacrificed, this part of their brain was infected with a spike protein. And when we looked at their brains, we saw inflammatory cells and we saw Lewy bodies. That's Alzheimer's disease and other neurologic diseases. These animals didn't have this before they were exposed. This is the result of the spike protein crossing the blood-brain barrier, which is exquisitely good at, and getting to its target. There's a doctor, a PhD by the name of Kevin W. McCarran in Japan, who's done more research. He is probably the world's expert on animal models, on primate models, and these diseases. And for a year, Dr. McCarran has been warning the world that this is going to have, that this spike protein crosses the blood-brain barrier and will have damaging neurologic effects like it did on the monkeys. He's done animal models showing what happens when you damage this part of the brain, and his animal models match exactly this type of damage with neurologic disease. There are scientists around the world trying to address this problem and bring home the information that you need.